Nutrition Science, Introduction to Nutrition Science and Information Literacy. If you follow nutrition science in the media for long enough, you'll start to see recurring themes. You'll see stories in the news about many of our favorite foods, like eggs, butter, coffee, and chocolate, that seem to flip-flop about whether these foods are good or bad for us. You'll notice seemingly eternal debates about whether dietary fat and carbohydrates are valuable macronutrients or villains. You'll watch as particular diets come in and out of fashion and then back into fashion another decade or two later. And you'll see countless clickbait stories about the health benefits of eating so-called superfoods or the dangers of eating others. Even if you don't pay much attention to nutrition science in the news, you'll hear a ton of conflicting opinions and information just by talking to the people around you. Maybe your best friend has gone gluten-free, or your dad is on a keto diet, and your coworker swears the Whole30 diet has been life-changing. They're all trying to convince you to join them in their latest diets, but your head is swimming. They can't all be right, and you don't want to just follow the latest fad. You want to find accurate information that's based on solid scientific evidence. How can you identify it in a sea of conflicting and overwhelming information? Who can you trust? It can be hard to filter through it all, especially when it's attached to strong opinions, emotions, and people trying to sell their product or point of view. And yet, we all need to make choices about what to eat, at the very least for ourselves and often for others. You may have the responsibility of feeding family members in different stages of life with different needs and preferences. And if you work in the health professions, you may have patients or clients who look to you as a source of reliable information about nutrition. Of course, the problem of conflicting and overwhelming information is not unique to nutrition. You'll find the same issue in many other health-related fields and beyond. Now, more than ever, it's essential to develop skills in information literacy, including the ability to find information, evaluate whether it is accurate and useful, and apply it effectively. The purpose of this unit is to develop and hone your skills in information literacy as it applies to nutrition. You'll learn about the scientific method because it forms the foundation of how we know what we know about nutrition. You'll learn about the different types of research studies and each of their advantages and limitations. We'll discuss various sources of information, such as scholarly and popular sources, how each of them can be useful in different ways, and how to evaluate them. We'll also discuss careers in nutrition and the different types of skills that you'll find among nutrition experts. The scientific method. Similar to the method by which a police detective investigates a crime, nutritional scientists discover the health effects of food and nutrients by first making an observation and posing a question that they'd like to answer. When they formulate a hypothesis, test their hypothesis through experiments, and finally interpret the results. After analyzing additional evidence from multiple sources, they may form a conclusion on whether the food suspect fits the claim. This organized process of inquiry used in forensic science, nutritional science, and every other science is called the scientific method. The basis of what we know about nutrition is derived from research, and the scientific method underlies how research is conducted. The steps of the scientific method include observation or questioning. The researcher makes first an observation and comes up with a research question to investigate. 2. Hypothesis. The researcher formulates a hypothesis or educated guess that would explain the observation or question, and that can be tested through scientific experiments. 3. Experiment. The researcher designs and conducts an experiment. A good design takes into account what has been done previously. Thus, before beginning a new study, the researcher undertakes a thorough review of published research in order to ensure that their work advances the field. 4. Analysis. The researcher collects and analyzes data that will either support or refute the hypothesis. If the hypothesis is not supported, researchers create a new hypothesis and conduct a new experiment. If the hypothesis is supported, researchers will design additional experiments to try to replicate the findings or to test them in different ways. Conclusion. After multiple experiments consistently support a hypothesis, researchers can often offer a conclusion or theory. The scientific method is a cyclical process because it always leads to new observations and questions. Through the scientific method, our knowledge of science builds continuously over time. No one study is enough to fully explain any one phenomenon, particularly in an area as complex as nutrition. Even experiments that go exactly as expected lead us to new questions to investigate. Science is also filled with surprises, both big and small. Experiments may not yield the results that we expect, but that can lead to new and important questions. And because scientists are human, they can make mistakes along the way or fail to acknowledge or test an important variable, which is why it's important that experiments be repeated and evaluated by other researchers along the way. The history of nutrition is full of fascinating examples of the scientific method at work, such as the discovery that iodine is a nutrient. This story of scientific discovery began in 1811 when French chemist Bernard Courtois was isolating a substance called saltpeter, an ingredient needed to make gunpowder to be used by Napoleon's army. Part of his isolation procedure involved burning seaweed. When he did this, he observed the release of an intense violet vapor, which crystallized when he exposed it to a cold surface. He sent the violet crystals to an expert on gases, Joseph Gay-Lussac, who identified the crystal as a new element. It was named iodine, the Greek word for violet. The following scientific record is some of what took place in order to conclude that iodine is a nutrient. Observation. Eating seaweed is a cure for goiter, an enlargement of the thyroid gland in the neck. The hypothesis is that seaweed contained iodine and that this Swiss physician, Jean-François Condet, that he could use iodine instead of seaweed to treat his patients. The experimental test that Condet did was to administer iodine tincture orally to his patients with a goiter. In order to interpret the results, Condet's iodine treatment was successful in treating patients with goiter. Gathering more evidence. Many other physicians contributed to the research on iodine deficiency and goiter. Hypothesis. A French chemist in 1851, Chatin, proposed that the low iodine content in food and water of certain areas far away from the ocean were the primary cause of goiter, and renounced the theory that goiter was the result of poor hygiene. An experimental test was in the late 1860s, several French villages began giving out iodine tablets and salt in an effort to treat goiter. To interpret the results, the program was effective and 80% of goitrous children were cured. However, adults did not always respond well to the treatment, and because men with goiter were exempt from service in the French military, some people were opposed to treating it. Some scientists also insisted that goiter was caused by infectious disease, so iodine wasn't yet accepted as a means of preventing it. It took more than 100 years from iodine's discovery as an effective treatment for goiter until public health programs recognized it as such. Although a lengthy process, a scientific method is a productive way to define essential nutrients and determine their ability to promote health and prevent disease.